Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about chemical bonding chapter. In the previous sessions we have seen different concepts from this chapter like what are chemical bonds, how many kinds of chemical bonds are there, about ionic, covalent and dative bonds. About this all we have seen some concepts. Now based upon this we are going to see practice sheet 2 now. This practice sheet contains questions like multi-correct answer, statement type, assertion reason, analytical approach questions. These all will be included in this chapter practice sheet. Okay, let us start the practice sheet. First, let us see the multi-correct answer type questions. See the first one. Which of the following elements do not participate in the bond formation? Is around 118 elements were known till date, isn't it? They have discovered so far 118 elements. Out of these 118 elements, very few elements are being stable. They do not participate in the bond formation. They are more stable. Except those elements remaining are being reactive and they are participating in the bond formations. Those elements which are not participating in the bond formation, which are being stable, are known as noble gases. They are helium, neon, argon, krypton, xenon, radon. These elements are being stable elements and they do not participate in the bond formation. So these are called noble gases. Okay, next one. Which of the following elements acquire stability by losing electrons? Yes, generally the elements which come under metals which are having one or two or three valence electrons, generally they lose those electrons and they form cations. So generally metals they do lose electrons and they form cations. See, out of the given four which are metals, you know, sodium is a metal, so it loses electrons to form cations to attain stability. And even calcium also, because it has two valence electrons, it will lose those two electrons and forms a stable configuration of nearby noble gas. Okay, argon. But these two elements they will gain electrons to become stable. Okay, sodium and calcium acquire stability by losing electrons. Next one. Identify the correct statements from the given. See, first one, ionic compounds are soluble in water. Yes, this is correct statement, isn't it? Ionic compounds are fairly soluble into water. For example, sodium chloride if we take, it is fairly soluble into water. Next one, the melting and boiling points of ionic compounds are high. Is it true? The melting and boiling points of ionic compounds are high. Yes, it is also correct. Because ionic compounds are having high melting and boiling points. They have that ions are held tightly with the strong electrostatic forces. That's why they have high melting and boiling points. What about the next one? Ionic compounds conduct electricity in the solid state. No, it is not true because in the solid state, in ionic compounds, ions are held tightly with oppositely charged ions. So in the solid state, ionic compounds they do not conduct electricity. Okay, they can conduct electricity only in the aqueous state or in the fused state, but not in the solid state. So the next one, reactions between ionic compounds are very rapid in solution state. Is it correct? Yes, ionic compound reactions are very rapid. They participate in the reactions very faster. This is also correct statement. These three are correct except the third one. Okay, next statement. Next question is see. Identify the correct statements regarding the formation of cation. See the first one, formation of Na plus ion is very easier than Mg plus 2. Yes, it is correct. Because sodium has only one valence electron. By losing that one electron, it becomes stable. So Na plus is formed easily. Whereas if you see Mg plus 2, magnesium has two valence electrons. To become stable, it should lose those two electrons. So loss of losing of two electrons is somewhat difficult than losing of one electron. because after the losing of one electron, nuclear force of attraction increases on the remaining electrons. Hence, for the removal of second electron, it requires a more amount of energy. That's why the formation of Na plus ion is easier than the formation of Mg plus 2. Next, next statement. Potassium forms cation easily than sodium. Yes, this is also correct. Because if we observe, sodium and potassium both belong to same group, isn't it? So, in a group from top to bottom, size increases. So, among between these two, sodium and potassium, potassium is having greater size. The atoms with the greater size can lose electrons easily because as size is more, the distance between the nucleus and the valence electron will be greater. Hence, nuclear force of attraction on that electron will be less comparatively. So that can be removed very easily, and hence we say the atoms with the greater size have lower ionization energy. They can lose electrons easily. Now here, in between potassium and sodium, potassium has greater size, and hence it is uh, having lower ionization energy, and can form cation easily when compared to sodium. Next one. Elements having more ionization potential form cations easily. No, it is not correct. Because elements with the greater ionization potential will lose electrons with difficulty. For the removal of electrons, it requires a greater amount of energy, but not easily. Okay. Next one. Elements with a smaller size form cation easily. The elements with the smaller size cannot lose electrons easily. So they cannot form cation easily. So this is also wrong statement. Only first two are correct. Okay. Next question. Identify the molecules with pure covalent bond. So a pure covalent bond is formed when two atoms share electron pair mutually, equally. Then a pure covalent bond is formed. Non-polar covalent bond is formed. Generally, the atoms with the zero electronegativity difference are the atoms which are having no electronegativity difference between them only can form a pure covalent bond. That means, to say simply, the covalent bond between two similar atoms will be purely covalent or non-polar covalent. So here, the covalent bond formed between similar atoms in H2 molecule, because two are hydrogen atoms only, and Cl2 molecule, O2 molecule. In this, both the atoms are of same kind. Then electronegativity will be same, and electronegativity difference will be zero for those. If they have both the same electronegativity, bond pair will be shared exactly equal, and hence there will be no polarity. Then the molecule is called non-polar molecule or non-polar covalent bond it is. But here if you see HCl, chlorine is more electronegative, hence it forms a polar covalent bond. So only these three are non-polar covalent molecules. Next, next question. Identify the molecules with multiple bonds. Multiple bonds means the bond formed by the sharing of more than one pair of electrons between the two atoms is called multiple bond. Generally double bond and triple bond are considered as multiple bonds. See here, nitrogen molecule has three covalent bonds between two nitrogen atoms, isn't it? In the same way, oxygen molecule also. It has two covalent bonds between two oxygen atoms. So these two are the molecules having multiple bonds. Don't be confused here. Methane molecule also having four covalent bonds. But here these four covalent bonds are formed between carbon and four hydrogens. Between two atoms there exists only one bond. If you see between this carbon and hydrogen only one covalent bond. Between this carbon and hydrogen only one covalent bond. In between two atoms if there are more than one bonds then they are called multiple bonds. In the same way, in the nitrogen molecule also, ammonia molecule, sorry, in the ammonia molecule also, there are three covalent bonds. But when hydrogen and nitrogen, there will be only one covalent bond. Okay, so these two are the correct answers now. Next one, which are not true about a non-polar covalent bond. Non-polar covalent bond means pure covalent bond. We can say the electron pair is shared equally by bonded atoms. Yes, if it is said to be non-polar, the covalent bond or the pair of electrons should be shared between the two atoms equally. Then only it is said to be non-polar. That is correct. Okay, this is actually correct about it, but it is not the correct answer. Okay, let us see here. They're asking not true. Now, if you see the next one, the electron affinity difference between the atoms is very large. Yes, then only it is said to be polar molecule. But here asking about non-polar. So this statement is not correct about non-polar covalent. So it is correct answer here. The electron pair is shared unequally by the bonded atoms. So it is also not correct because in the non-polar covalent molecules, electron pair is equally shared. So this is also not correct about non-polar covalent bond. So now it is also correct answer. The electronegative difference of the atoms is large. So this is also not correct about non-polar. So it is also correct statement because they're asking about not true about non-polar. Only this is the statement which is true about non-polar covalent. The remaining three are non-correct. Okay. Next, let us say a comprehension passage. On that we have to see some questions. Atoms can complete the valence shell by acquiring octet configuration two ways. One by sharing, another by transfer of electrons. Okay. Now, let us see the questions based on that. See the first question. To attain dash, participating atoms redistribute their electrons to get a electronic configuration of the nearest noble gas, either octet or duplet. How do they attain? To attain a state of minimum energy and a state of maximum stability. So, minimum energy and stability. These two will be attained by an atom after the bond formation. So to attain these only, atoms participate in the bond formation. Minimum energy and maximum stability. So these two are correct. Now what will be correct answer? This. Okay. Next one. By which of the following atoms attain stability? So in attaining stability, atoms sometimes they transfer electrons and they share electrons. Even by lowering energy also atoms become stable. By these two, obviously they attain lower energetic state, either by transfer of electrons or by sharing of electrons. So by these three ways, atoms attain stability. Now correct answer will be this. Next, the chemical stability is more for generally, except noble gases, the atoms of other elements are unstable because they don't have octet configuration. So, in attaining that, they form respective ions either by losing or gaining alpha electrons. After formation of ions, they attain stability. So, chemical stability is more for their ions except noble gases instead of than the parent atoms. Their ions are being more stable because they will be attaining stability either by losing or gaining electrons. Okay. Next, one more passage is given here. The bond formed by equal contribution and equal sharing of electrons between two atoms is known as a covalent bond. Okay, about covalent bond, they're going to give some questions here. See the first one. Which of the following molecules has more number of shared pair of electrons? Yes, shared pair of electrons means the pair of electrons which are participating in the bond formation is called shared pair of electrons. And the pair of electrons which are present in the valence shell of an atom and not participating in the bond formation is called a lone pair. Now they're asking about shared pair of electrons. If you see nitrogen molecule, in nitrogen molecule, there are two nitrogen atoms. Both are sharing three pairs of electrons, isn't it? Three shared pair of electrons are now, and there is a lone pair on each nitrogen atom. Now, in this molecule, there are three shared pair of electrons. What about oxygen molecule? In this, each oxygen atom share two pairs of electrons, and hence two shared pair of electrons are there in the oxygen molecule. What about chlorine molecule? In chlorine molecule, each chlorine contributes one electron for sharing. Thus, they share a pair of electrons. So one shared pair of electron. And if you see in methane molecule, central atom is carbon. It shares one electron with each hydrogen, and hence it forms four covalent bonds, isn't it? Thus, the central atom carbon is having four shared pair of electrons. Now, which is having more number of shared pair of electrons now among all? Methane. Methane has four shared pair of electrons, right? Next, the covalency of oxygen in water molecule. So we know in oxygen molecule, central atom is oxygen. It has six valence electrons. Out of six valence electrons, one is shared with one chlorine atom, one hydrogen atom. Now what they're asking, covalency. Covalency means the number of electrons shared by an atom in the bond formation is called its covalency. Oxygen is sharing or contributing two electrons. So its covalence is said to be 2. Covalence can be defined as now the number of electrons contributed by an atom in the covalent bond formation, or the number of electron pairs shared by an atom in the covalent bond formation is called its covalency. If you see in the water molecule, oxygen sharing two pairs of electrons, hence its covalence is 2. Okay, next one. Which among the following is a covalent compound? See, generally, the covalent bond is formed between two nonmetals or the elements which are having less electronegativity difference. Between them, generally, covalent bond is formed. If you observe the molecules here, rubidium fluoride, it is a metal and fluorine is a nonmetal. Magnesium chloride, magnesium is a metal and chlorine is a nonmetal. And here in calcium oxide also, calcium is a metal, oxygen is a non-metal. Generally these all will be ionic bonds. Generally the bond formed between metal and non-metal will be an ionic bond, because metals they will lose electrons, non-metals they will gain these electrons, hence they will be ionic bonds. Whereas in the ammonia molecule both are non-metals, so instead of losing or gaining electrons, they share electron pairs between them, hence it is a covalent compound. Okay, next let us see matrix matching type questions. So here two columns are given. See the first one, best polar solvent. What is the best polar solvent? We know water is the best polar solvent. It dissolves most of the polar substances into it. Ionic compounds in solid state. What about ionic compounds in solid state? They do not have mobility of ions, because in solid state ions are held together by strong electrostatic force of attractions. Hence, they do not have any mobility for their ions. So, as there is no mobility for the ions, ionic compounds in the solid state are bad conductors of electricity, isn't it? Next, ionic compounds in the molten state. Ionic compounds in the molten state, they split into respective ions. Suppose if you take sodium chloride and dissolving to water, it splits into Na plus and Cl minus ions. So that is splitting into respective ions. As there are splitted respective ions, they can conduct electricity. So they become good conductors of electricity in the molten state, because it is splitting into respective ions. Because of the presence of ions, they can conduct electricity now in the molten state. Next, in the aqueous state, ionic compounds in the aqueous state. In the aqueous state also, ionic compounds split into respective ions. As they split into respective ions, they can conduct electricity in the aqueous state also. Molten state and in the aqueous state. Sorry, molten state means melted form. Fused state it is called. Aqueous state means when dissolved into water. In these two states, ionic compounds they split into respective ions and hence they are good conductors of electricity. Okay, check the matching once again. Okay, let's go to next question. See here, some molecules are given and asked to calculate number of lone pairs and bond pairs in them. Now, nitrogen molecule. We know in the nitrogen molecule, central atom is two nitrogen atoms are there. They share three pairs of electrons between them, and they have a lone pair of electrons on each. Okay, if you see water molecule, in the water molecule, central atom is oxygen. It is forming two covalent bonds with the two hydrogen atoms, means two shared pair of electrons. And on the oxygen, there are four more electrons in the form of two lone pairs. And if you see oxygen molecule, in these two oxygen atoms, they share two pairs of electrons between them, and each oxygen will be having four more electrons. That means two lone pairs on each. Okay, if you see HCl molecule, between hydrogen and chlorine, they share a pair of electrons. After sharing, there are three more pairs of electrons on the chlorine which are not shared. So they are called lone pairs of electrons. Now let us try to match these. See the first one, nitrogen. It has three bonded pairs of electrons and two lone pairs. So there is two lone pairs. Here it is. Two lone pairs and three bond pairs. Nitrogen molecule has two lone pairs and three bond pairs. And what about water molecule? In water molecule, if you observe, totally there are two bond pairs and two lone pairs. So two lone pairs and two bond pairs, isn't it? Next, if we see oxygen molecule, there are two bond pairs and totally there are four lone pairs. Okay, two bond pairs and four lone pairs. So we can cut it here. We can connect here four lone pairs and two bond pairs. Next, if we see next one, HCl molecule. In this HCl molecule, there is only one bond pair. It is not mentioned here about one lone pair, one bond pair, but there are three lone pairs. Here it is three lone pairs. Okay, this is a correct matching. Observe once based upon the number of lone pairs and bond pairs. Okay, let us see next one. Assertion reason type questions. See the assertion. Silicon shares electrons in forming the bonds. Yes, silicon has four valence electrons in the outermost shell. So that is why it cannot lose or gain electrons. Instead of these two, it will share the electrons. Next reason. Silicon has four electrons in the outermost orbit. Actually, both are correct statements and it is the correct reason for the assertion. So it will be correct answer now. Okay, as it is having four electrons, it cannot lose or gain, it will share electrons. Next, analytical approach questions. See the first one, if stability is attained with 6 electrons rather than 8 electrons, what would be the formula of the stable fluoride ion? So generally the electronic configuration of fluorine is 2 comma 7, isn't it? It has 7 electrons in the outermost shell. To attain octet configuration, it gains one more electron and forms fluoride ion F minus ion generally, because it should get 8 electrons in the outermost shell. But here it is mentioned it will attain the stability by 6 electrons. Already it is having 7 electrons. To attain the stability by 6 electrons, what it can do? It can lose one electron so that it will get to 6 electron in the outermost shell and hence becomes stable. So by losing one electron, what happens? It forms F plus ion. Fluoride ion will be formed by losing one electron. That is F plus ion. Okay, as per the condition given here. Next, the atomic numbers of three elements A, B, and C are A plus 1, and A plus 2 respectively. And C is an alkali metal. In a compound A and C, the nature of the bonding is. So here it is mentioned C is an alkali metal with atomic number A plus 2. So if it is C is an alkali metal, what will be the before element to alkali metal? Noble gas. So this is an all noble gas, that is 8th group element, because for every alkali metal the before element will be alkali noble gas element, and before the noble gas in periodic table there will be halogen. So the element A is a halogen, C is an alkali metal. So the chemical bond between the alkali metal and halogen will be ionic bond. For example, if you take sodium and the alkali halogen before that will be fluorine. Suppose it is a sodium. What is the before element to alkali metal sodium? Neon, isn't it? Before neon there will be fluorine. Now the bond formed between fluorine and sodium will be ionic bond, because non-metal and metal those two are. One will lose electron, other will gain electron, and hence they form ionic bond. Okay. Next, the melting points of molecular compounds are usually molecular compounds means covalent compounds, which are formed by sharing of electrons. For this, melting and boiling points will be lower, because there will be weak force of attractions between the molecules. They are lower than that of ionic compounds. Okay, next one. Octet rule is not valid for the molecule. So octet rule means after the bond formation, all the atoms they should attain octet count, 8 electrons in the outermost shell by sharing. But here if you see, between oxygen and carbon there is a double bond. Oxygen will get octet, but carbon, it has 4 electrons in the valence shell, it is sharing 2 more electrons, it is getting only 6 electrons after the bond formation also. So it is the molecule which is not getting octet. It is, we say, while octet rule is not valid here. Okay, next one. If the atomic number of an element is 7, the best electron draught symbol for the element is. So as it is having 7 valence electrons, its configuration will be 2, 5. So in the valence shell it is having 5 valence electrons. In the Lewis dot structures, the elements in the electrons in the valence shell are represented as dots around its symbol. As it is having 5 valence electrons, there should be 5 dots. See, it is the correct representation of that element. Okay, this is a practice sheet related to the chapter chemical bonding. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.